This is part 2 of decision making under risk. So we've already in part 1 talked about uncertainty and looked at some payoff tables. And so this week the only focus is on expected value and expected value of perfect information. So just like last week where we had a payoff table, we might have, particular states of nature and then of course come up with various alternatives. The only thing we're going to add now is what if we actually knew some actual probabilities, okay, of these states of nature that they would actually occur. So then what we could come up with is this expected value based off of these probabilities. So as you can see, each one of these are weighted, it's like a weighted average by the particular probability, and we could get an expected value. And then by looking at all of these, we could certainly see the best one to go with would be alternative 1, because that would give us our highest payoff. All right, so that's the only thing really different here from last week, is maybe looking at the probabilities and put actual weights on these. All right, this next example actually goes through, if you've been wondering, how do they actually come up with a payoff table? So to create a payoff table, let's say this is some production example. They're producing some item, and we can produce either 1,000, 2,000, or 3,000. And we know that the company, a company is going to demand either 1,000, 2,000, or 3,000. We don't know how many they're going to demand. And then the probability of each one of these demands. And associated with this, we also have production cost, which would be, $150 per 1,000. Sales price, 200. Outside purchase, in other words, outside purchase, if they don't make enough, they would have to go outside and make this purchase to be able to meet the demand. And then scrap value, if they make too many, how much they could actually get for that scrap. All right, so this just shows the 3 different scenarios that could happen. In other words, the company doesn't know the demand in advance. So they're either going to produce 100 items, 1,000 items, 2,000 items, or 3,000. If they produce 1,000, so you can look at each one of these, and I re-put my table over here, then I could see that the revenue, okay, the sales price would be 200. For demand of 2,000 would be 2 times that value, and then 3,000 would be 3 times that value. Okay, so that would give me my sales price. And then the next line here is my cost, where if we're only producing 1,000, and this is per 1,000, then my cost for each one would be 150. And then next here, the outside purchase. So if we produced 1,000 and they really wanted 2,000, then we're going to have to go outside somewhere, maybe to a competitor, and actually purchase these items so we can meet their demand. And then, of course, at 3,000, if we only produced 1,000, then we would have to do 2 times this outside purchase. And so from here, then you can see this bottom row, depending on what actually we produced in this case, based on their demand, would be our payoffs. And each one of these scenarios goes through that. So you can certainly see the sales price is going to be the same for each one. What's happening with the, if we produce 2,000, now in this case, then our production cost is 2 times the 150. And then if we produce 2,000 and they demanded 3,000, then we actually have to go out and make another purchase to meet the extra 1,000. If they demand 1,000 and we made 2,000, in other words, we produced too many, then we would have this scrap value. And so we total all those up to get our payoffs. Do the same thing here. So once again, as you can see, the sales price is going to be the same. The cost now is going to be 3 times the 150. Okay, and so outside purchases, well, if they produce 3,000, they're not going to have to make any outside purchases, but if they produce 3,000 and the demand was 1,000, then they'd get scrapped 2 times the 50, and also 50 if the demand was 2,000. So what you can do is what I have highlighted here, you can create an actual payoff table from this information. And that's what you see. You can see each line here. And then you could get your expected value, just as we did on the example before. So this is just a way if you are interested in how do they actually come up with the payoff table. All right, so from here, what if we knew we had some insider information, which might be against the law, right? But what if we knew going in advance which state of nature would occur, and you would want to pick the highest alternative with the largest payoff? So in other words, in this case, the highest payoff for each state of nature would be 50, 100, and 150. So what we could do, if we knew this ahead of time, we can multiply the probabilities, okay, each one of the probabilities by these states of nature, and we get this value, 95. The difference between this value and our expected value is what's called expected value of perfect information, which is the maximum amount that you would actually pay somebody to know this information of which state of nature would occur. So if somebody said, hey, would you pay $20 for it? Well, yeah, that would be worth it, right? You'd still be making a profit, but if they said 50, then it may not actually be worth it. So that's the expected value of perfect information.